Hey everybody, today we're looking at 9.5, transforming parent functions, day one. So transformations change the location or size of a figure, and these transformations can be applied to parent functions. You guys saw these in geometry, doing rotations, reflections, slides, things like that. So today we're going to look at two of them. We're going to look at vertical translations, which move things up and down, and horizontal translations that move things left to right. So a vertical translation is something when you have a function, it's happening on the outside of the function. So if you've got like a plus something on the outside of the function, that's moving it up, whatever that amount is that you're added. If you've got a function and you're subtracting something from it, then that's going to move it down, whatever amount you're subtracting. So we're going to identify the parent functions and then say what transformations are happening to them. So number one, I see an x squared. So an x squared is a quadratic, and its parent function is y equals x squared. That minus 4 is outside of the x squared, so it is making it move down 4. Number 2, I see those bars. Those bars tell me it is an absolute value function, and its parent function is just an absolute value of x. And that plus 5 is outside the absolute value of x, so I know I'm going up 5. 3, I see an ln x plus 3. There really should have been parentheses. That was a typo on that ln of x. And that is a logarithm, so a logarithmic function. And its parent function is ln of x. And that plus 3 is outside of that natural log, so it is moving up 3. And finally, y equals, or m of x equals x minus 6. So that x doesn't have an exponent, so I know it is linear. So its parent function is y equals x, and that minus 6 is telling me it is moving down 6. The other type of transformation we're going to see are horizontal translations. So this is when it's inside the function. So when it is inside the function, that's when you've got like an f of x and the transformation is happening inside of it, so inside parentheses or inside the function. So if you're adding inside the function, that's going to make it go to the left, whatever amount you're adding. And if you are subtracting inside the function, that's going to make it go to the right, whatever amount you are subtracting. So really, the way I think about it is it's the opposite of what you'd think. So what I mean by that is normally if I see a plus sign, I would think go to the right, but really it's going to send it to the left. It's because if you set it equal to 0, it would change signs. Same with like a minus sign, I usually would think to the left, but it's actually to the right. And again, it's because if you set it equal to 0, it's going to change the sign. So looking at 1, I see just an x with no exponents, so that's telling me it is linear. The parent function is the y equals x. And because they put parentheses, they're trying to show you that they're saying it's inside the function, so it would go to the left 5. Number 2, I see a square root sign, which is a radical. And its parent function is square root of x. That transformation, it's a minus 2 inside of the radical. So if it's inside the radical, that's telling me it is going to the right 2. If it had been something like outside of the radical with that minus 2, that would have been a down 2. So that's kind of what we mean by inside versus outside. Number 3, there's a 3 on the outside, so it's the biggest exponent, so it is cubic. So y equals x cubed is the parent function. So that plus 2 is inside of the cubed. So because it's inside the cubed, that's telling me it's going left or right, and the plus sign tells me it's going to the left 2. And then on number 4, I see an x on the bottom of a fraction. So x on the bottom tells me it is a rational, and rational's parent function is 1 over x. So that minus 2 is with the x on the bottom of the fraction, which is telling me inside. So that is going to the right 2. If it had been something more like 1 over x and then the minus 2 was outside the fraction, that would have told me down 2. All right, flip the page. So looking at this next page, we are now looking at a graph and having to identify the name, the parent function, and what transformation happened. So I see that this graph had a starting point and went forever to the right. So it never went negative, which helps remind me that it's going to be a radical because you cannot take the square root of a negative number. And the transformation, originally a radical function starts at 0 and looks like this. So you can hopefully kind of see that it went up 1, 2, 3. So it went up 3 from its original parent function. The second one, I see a U shape, and a U shape immediately tells me quadratic. So y equals x squared. So a parent function for a quadratic starts at 0 and is a U shape going up. So this U shape has moved down 1, 2, 3, 4, 5, 6. So I went down 6 is my transformation. Number 3, I see that kind of like S curve, which tells me it is cubic. And a parent function for cubic is an x cubed. Cubic functions also go through the origin, so they look like this. So this one moved 1, 2, 3, 4, 5 is what it looks like to me. So this one moved to the right 5. All right, looking at number 4. So this one is a rational because it has those 2 loops in the corners, which is a y equals 1 over x. So originally what a rational looks like is like this. I guess I should be drawing dotted lines like this and like this. And we talked briefly, I think last class, about how there's these asymptotes. So an asymptote is an invisible barrier that cuts through the x-axis and the y-axis that graph gets close to but never touches. So you can kind of see that this has shifted. So this center line between the 2 curves has shifted over to here. So that kind of helps tell me what the transformation was that happened. So it started on the x-axis, and then that center line moved over 1, 2, 3. And then the new asymptote is kind of cutting it in half there. So this one went to the left 3. Ooh, number 5 has 2 transformations. First, I see it's a v, so I know v tells me it's an absolute value function. So the parent function is those absolute value bars around the x. Absolute value originally looks like this. It starts at the origin and makes a v. So this has moved over to here and here. So it went 1, 2, 3 to the right. And it went 1, 2, 3, 4, 5, 6 up. So this one's got 2 transformations going on. Number 6, again, I see a starting point curving. So when it starts and curves like that, that's a radical function. And that is created by a square root. So that square root moved over 1, 2, 3, 4. So it went to the left 4. All right, number 7. Oh, I see another radical. So it's got a starting point and it curves to the right. So that original function is here. So it's a radical. And it moved 1, 2. So it's moved over 2 to the left. And it goes up, looks like it's going up 3. Number 8, it's got that little curve, so I know that's a cubic. So it's y equals x cubed. Originally, cubic touches the origin, so we're kind of using that center point to help us figure out the curve. So if I look at the center of that curve, it looks like it's hitting here. So that center curve goes, it's up here at 2. So this one looks like it went to the right 2. And if I connect it to this side, it looks like it went down 3. Finally, 9, I see a U-curve, so a U-curve tells me quadratic. And the parent function is y equals x squared. Quadratics start at the origin and make a U. So this U's center point, or vertex, moved to the right 1. And 1, 2, 3, 4, 5, 6, and up 6. Okay, so now we've looked at it on pictures, and we have looked at it in an equation. So now let's try to draw our own. So here we have been given an equation, and we want to know what transformations have happened. So I know this is a quadratic, and they've given us the parent function. What transformation occurred? So I see plus 4 outside of the x squared, which tells me it is going up 4. So those points of the original parent function, I'm going to move each of them up 4 to create the transformed function. So that center point, I'm going to go up 4. Those ones around it will both go up 4. And then the other points will also go up 4. So I'm going to draw my new U shape. That wasn't very good. There we go. Oh, still missed it. Whatever, you got the idea. So I'm connecting those dots to make the transformed quadratic that is shifted up 4. On number 2, that minus 4 is inside the parentheses. So that quadratic is being shifted to the left 4. So if it's inside of the function, it moves left or right. Oh, and I did it wrong. See, it tricked me. Going backwards. If it is a minus sign, we do the opposite of that. So it is going to the right 4. That's my bad. So we're going to go 1, 2, 3, 4, and then move each of those points 4 to the right. So my new transformed quadratic looks like this. All right, number 3, I see a cube, so I know that's a cubic, and you can see that nice S shape. That minus 7 is outside of the x cubed, so outside tells me up or down, so it is going down 7. So each of these points, I'm going to move down 7. Notice the one on the left, you really can't move it down 7 because it goes off the graph, so we're just going to ignore that one. So my new cubic function that went down 7 looks like this. Number 4, we have a rational, because x is on the bottom, so you can see those two curves. And that plus 5 is outside of the x of the fraction, so I know that it is going up 5. So you can think about it as that asymptote, so that center line that's cutting through the middle of this is going to move up 5. So 1, 2, 3, 4, 5. So my new asymptote is here, so that's what it should be centered around. We're also going to count and move those dots up 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. The center asymptote is really still on the y-axis. It didn't move because it just went up, so it stayed the same. So my new function is going to, let me not do that in highlighter. It's going to look like this. So it's going to get close to those asymptotes, but it shouldn't actually touch them. So that is our rational function shifted up 5. All right, 2 more. So this one, we've got an ln of x, so I know it's a logarithmic function. And then plus 3. So the plus 3 outside of those parentheses means up 3. So that point they gave us is going to go up 3. And I think we maybe talked a little bit about the asymptote on this one as well. So even though you can't see it very well with that dotted line, it's getting really close to the y-axis but not touching it. So when I draw it, it's going to go along the y-axis and then go through that point and then start curving and flattening out. Finally, we have an absolute value function. This one's got 2 transformations going on. So that minus 2 is telling me to the right 2. And the plus 7 on the outside is telling me up 7. So each of these points is going to go to the right 2 and up 7. So I'm going to start with the middle. So it's going to go to the right 2 and then up 7. 1, 2, 3, 4, 5, 6, 7. And then those points around it, you can kind of just see where they should go based on the picture, but they're all going to the right 2 and up 7. So that is the absolute value function, to the right 2 and up 7. All right, I hope this was helpful, and good luck with your practice.